Hello students, today we are going to be solving radical equations. When doing this, there are several steps that we need to go ahead and look at. The first step is that we are going to isolate the variable. The next step is we are going to raise both sides of the equation to the same power in order to eliminate the radical. If you have a rational exponent, you're going to raise both sides to the reciprocal power. The third step is to solve for x, and the last step is to check for extraneous solutions. We've done this before, so make sure to take care of that last step. Let's go ahead and look at some examples. The first example, I have the cube root of 2x plus 7. So my first thing is to isolate the variable. My variable, the only way to isolate that is to take the cubed of both sides to get the x by itself. So I'm going to cube both sides. I'm going to raise both sides to the third power. So the cube root and cube cancel out. So I have 2x plus 7 is equal, 3 cubed would be 27. I'm going to subtract 7 from both sides. So 2x is equal to 20. Divide both sides by 2. X is equal to 10. The last thing I need to do is check to make sure this checks out. So if I have the cube root of 20, 2 times 10 is 20, plus 7 is equal to 3. The cube root of 27 is equal to 3. And then I go ahead and know that the cube root of 27 is in fact 3, so 3 equals 3, so my solution is x equals 10. The next problem is x plus 2 all raised to the 3/4 power minus 1 is equal to 7. First thing, I need to get the variable by itself, so in order to do that, I need to add 1 to both sides. So I'm left with x plus 2 to the 3/4 power is equal to 8. Now, this is different because now I have a rational exponent. And if you remember, I need to raise both sides to the reciprocal. So the reciprocal of 3/4 would be raising both sides to the 4/3 power. So when I do that, the 3/4 and the 4/3 cancel. So I have x plus 2 is equal to 8 to the 4/3. I'm going to go ahead and put that into radical notation so I can solve. So I have the cube root of 8 all raised to the 4th power is equal to x plus 2. Well, I know that the cube root of 8 is 2, and then 2 to the 4th power is going to give me 16. So I have x plus 2 is equal to 2 to the 4th, which is 16. So x plus 2 equals 16. Subtract 2. So x is equal to 14. But I'm not done yet. I need to go back and check this. So if I plug it in, here's my check. If I plug it in, 14 plus 2 raised to the 3/4 power minus 1 equals 7. So 14 plus 2 is 16 to the 3/4 power minus 1 is equal to 7. Put this in radical notation, so the 4th root of 16 all raised to the 3rd power minus 1 is equal to 7. I know that the 4th root of 16 is 2, and then I need to cube that. Minus 1 equals 7. 2 cubed is 8. Minus 1 is 7. 7 equals 7, so that checks. So my solution is x equals 14. Let's go ahead and look at some more examples. This next example, I have x plus 1 is equal to 7x plus 15. In this case, I need to get this radical undone, so I'm going to have to square both sides. So when I do that, I'm left with 7x plus 15 because the square root and squared cancel, and then I have x plus 1 squared. So I need to go ahead and use FOIL, or just distribute your variables. So x and x gives me x squared. 1x plus 1x would give me a 2x, and then 1 plus 1 gives me 1. Then I have 7x plus 15. Now I need to solve for x, so I'm going to go ahead and subtract to get all my variables on one side. So I subtract 7x and subtract 15. So when I do that, this 7x cancels and this 15 cancels, and that's 0. So I have x squared, negative 7x plus 2 is a negative 5x minus 14. I'm going to go ahead and have to factor this, so I'm going to see what multiplies to negative 14 and adds to negative 5, which is going to be negative 7 and 2. So I have x minus 7, x plus 2 is equal to 0. Set those both equal to x, so x is equal to 7 and x is equal to negative 2. But I'm not done. I need to go ahead and check. So if I plug in a 7, I have 7 plus 1 squared is equal to 7 times 7, which is 49, plus 15, and the square root of that, which is the square root of 64. And I'm sorry, my original problem, I need to go erase that, was just x plus 1, which would just be 7 plus 1. So then I have 7 plus 1, which is 8, and the square root of 64 is in fact 8, so 8 equals 8. So we know that this is a solution. Now I need to check my negative 2. So I have a negative 2 plus 1 is equal to 7 times negative 2, which is negative 14, plus 15, and the square root of that. So that would be the square root of 1. Negative 2 plus 1 is a negative 1. Well, the square root of 1 is 1 equals negative 1, and that is not a true statement, so this is an extraneous solution. So my only solution is x is equal to 7. Let's look at one more example. This one is the same thing. I'm going to have to isolate this variable, so I'm going to square both sides. So I'm left with x minus 6 is equal to x minus 8 times x minus 8. I need to go ahead and use FOIL, so I have x squared, a negative 8x, and a negative 8x is a negative 16x plus 64 is equal to x minus 6. Once again, I need to get everything to the other side, so I'm going to subtract x and add 6. So that cancels and gives me 0. Subtract x and add 6. So I have x squared is equal to negative 17x and then plus 70. So I need to see what multiplies to 70 and adds to a negative 17, which would be negative 10 times negative 7. So my factors are x minus 7 and x minus 10, which would make my solutions x is equal to 7 and x is equal to 10. Once again, I need to check my solutions. So 10 minus 6 and the square root of that is equal to 10 minus 8. So 10 minus 6 is 4. Square root of 4 is 2. 10 minus 8 is 2. 2 equals 2. So I know that 10 checks. Now I need to check my 7. The square root of 7 minus 6 is equal to 7 minus 8. 7 minus 6 is 1. Square root of 1 is 1. 7 minus 8 is 1, so 1 equals 1. That checks, so I have two solutions of 7 and 10. We will go over any further questions tomorrow in class.